1. Metric spaces. Problem 1.5. Discrete balls. Let x, d be a discrete metric space, that is, x is endowed with a discrete metric. We want to characterize first all open balls and second all dense subsets. Solution to Part 1. Characterization of open balls. Recall that in a discrete metric space, the distance d of x and y is 0 if x equals y, and 1 if x is not equal to y. For any point x in x and any radius r greater than 0, the open ball centered at x with radius r is defined as u sub r of x, the set of all y in x such that d of x and y is strictly less than r. We distinguish two cases. First case, 0 is strictly less than r, and r is less than or equal to 1. Then the open ball u sub r of x is exactly the singleton set containing x. Indeed, the distance from x to x is 0, which is strictly less than r, so x belongs to the ball. If y is different from x, then the distance from x to y is 1, which is greater than or equal to r, so y does not belong to the ball. Thus, u sub r of x equals the set containing only x. Second case, r is strictly greater than 1. Then the open ball u sub r of x is all of x. Indeed, for any y in x, the distance from x to y is either 0 or 1, and in both cases, it is less than r. In summary, we have u sub r of x equals the singleton set containing x if r is between 0 and 1 inclusive, and u sub r of x equals x if r is strictly greater than 1. Solution to Part 2. Characterization of dense subsets. A subset A of x is called dense in x if its closure equals x, or equivalently, every non-empty open set in x intersects A. In terms of open balls, this means that for every x in x and every radius r greater than 0, the intersection of the open ball u sub r of x with A is not empty. In the discrete metric, every singleton set, the set containing only x, is open because it is exactly the open ball u sub 1 of x. Since arbitrary unions of open sets are open, every subset of x is open. Consequently, every subset of x is also closed because its complement is open. Therefore, the closure of any subset A is just A itself. So the only way for A to be dense in x is that its closure, which is A, equals x. In other words, A is dense in x if and only if A equals x. In this topology, the open sets are precisely all subsets of x, that is, the full power set of x. Every subset is both open and closed, also called clopen. For any subset A, its interior is A and its closure is also A.